disbelief right now. All right. So let's start off with any questions or issues or problems people are having?
I have a question about Sprint 4. With the part about the creating a sprite animation cycle between the two animated images, does that mean like swapping an image back and forth?
Yeah. So essentially, I'm going to draw it kind of like moronically here, but let's pretend this is the alien. So this is image A, and then you have image, this, and it's just going to be, and it's going to basically display on the screen, image A, and then turn around and draw image B. And it keeps swapping back and forth. So it just keeps swapping back and forth. And essentially that's motion pictures, right? It's just a lot of still images flipped sequentially and gives illusion of movement. The one thing that film does do in higher end rendering and graphics does is motion blur. So stuff that it's on the bleeding edge of movement is clear, and the stuff that's trailing tends to be a little bit integrated with the film. But we see you go to the movie screen, traditionally film is run at 24 frames per second. So it says flipping 24 pictures in 1 second. So it's really an illusion that things are moving. Nothing's really animating.
Thank you. And I have another question about factories. Well, basically, when we're moving horizontally across the screen, you know how the factory builds all of those sprites. So how can I tell when one of the nodes has hit the end of the wall? Like, can factories be columns, or do they have to be rows?
Factories can be anything you make. Okay. The movement, right? So let's distinguish something here. A factory will generate objects for you, and these objects you can then you can move them, you can move the objects around, you can draw them, you can do a lot of different things. These are just normal class objects, right? So the factory, its job is done as soon as it creates it. There's no more thank you factory, you're good job. And think about this, keep thinking about the car model, right? Once you buy a car from a factory, the factory is no longer responsible. It becomes somebody else's problem if you need to have fixed or you need a feature added or something like that. But they produce a product, gave you the product, it's done.
Okay, then which what's it called, class would be the most appropriate class to use to indicate to us that it's reached the edge and to like reset our value?
That's really up to you. You'll see a little bit more today. When we start talking about the composite pattern, some of the things you can do, but basically you're just gonna move it back and forth. You can sit there and check each of the boxes. You can move a certain amount of things. However you want to do it, you have a lot more flexibility here because we have not introduced collisions yet.
Okay.
Yeah. And
are we introducing collisions today?
We're starting collisions today.
Okay.
And the collisions are much more complicated.
Okay,
so there's a lot of things going on. Other questions? All right.
I have a question.
Chip.
Don't we have like a big midway sprint or something due in like a week or so?
Yeah, it's a milestone. We're going to go over that. Yeah.
Yeah. I was just wondering, not to put pressure on you or anything, but I'm just wondering if we're going to be getting our other sprints back before then, so we kind of know how we're doing.
Yeah. I'm literally being very sick with a migraine. So the last thing to do is watch videos. That's pending. It's coming. Remember, the sprints are there as a kick in the pants to keep you moving.
Okay.
And but no, I'll get you the feedback on that stuff. I was hoping to get the next one done today, but migraine said no. So
Sounds good. Thank you.
yeah, no problem. Good question though. All right, other questions? All right, so I want to kind of give you guys something that I have discovered, and I'm very mad at the world right now because I found an inconsistency in the literature and inconsistency with the way what's the word I'm calling iterators are done, right? And this triggered off a couple questions on, you know, what does is done do, and you know what, you know, how does some of the interface comes out of this, and also a little bit out of the PA assignments where we're kind of testing some of these things out a little deeper. And so kind of the short and skinny of it, the classic literature is you have a first function, you have a next, you have a current, and you have an is done, right? And what's interesting with this is literally in literature. This is when we sit there and Google things, kind of look at some of the diagramming of this stuff. Design iterators. Yeah, every once in a while you find something that's like inconsistent. And we can see here. First, next, is done, current, right? And we go to factory and iterator. And then here is again, first, next, is done, current, right? And then in the sample code here, they're looping and they kind of do this loop here. And, you know, I'm like going, oh, they missed the is done, all this sort of stuff. Well, they got me thinking deeper and deeper about this. Is like, I also seen the pattern has next. I don't know if you've seen that before. And what's really intriguing, design iterator. And you see this a lot in Java. And, you know, so here's the pattern here, but when looking at some of the code, it says has next, right? And it will sit there and say has next, and it has, you know, and then next, you know, so they have a couple of different schemes. So I'm like trying to get to the bottom of this, like how the heck are we talking different terms, different ways, and all this sort of stuff. So then I'm like, all right, let's go deeper. And so what I did is I put together an iterator. And this is just more a discussion and aside, but I think for at least to me, it clarifies this, and I bounced it off some of my students from last year, and they're like, oh shit, kind of thing. All right, so here's here's the iterator. Oh, here's scratch, right? And so here's the iterator, right? And it just has the current, first, is done, next, and we can kind of see that. You know, next, is done, first, right? So this is straight from the PA. And, you know, obviously you drive from it and you do all the magic stuff there. But then when you start to use it, so my unit tests where, we're testing the individual methods, right? So it's testing the individual methods. Was this PA2?
Yes.
Yeah. So it was testing the actual individual methods, which is appropriate. But oops. This is the pen. Did I click the right one? Oh, and from a unit test standpoint, that absolutely makes sense. But I want to show you this little side piece here that caused me some trouble. All right, so here's the unit test. And garage, I added all these cars, get the iterator, and then I can test the first, current, done, and then next, current is done, next, current. So I keep testing those 4 methods every time I basically call next and change this internal state, right? And this is absolutely correct. There's nothing wrong here. Even when we're dealing with an empty garage, the first should be null, the current should be null, is done should be true because there's nothing in the list. So there's no, you cannot increment to the next, right? So I'm like, okay, going through this stuff, but that Piazza post got me thinking, and I'm like going, I've always had some issues on the edge conditions about is done and does first and next and stuff like that. And this is why it's good to kind of shake this stuff out at a really intense level. So what I did here is I'm like going, let's just start using this, right? Let's use this. And so here's the iterator, and I just loaded up, garage, I loaded up with all the pandas, all the cars. So there's the cars, and I added them all, right? So this is just the beginning of the other test. And then what I'm going to do here, this next line is, how do we access an iterator, right? And what I've done before is kind of this scheme right here. And this scheme right here is where I'm having the issue, is that it feels wrong. Just because linked list, you tend to do a while and you do next instead of linked list. The iterator wrapping is actually designed not for that scheme, right? So here's how I was kind of showing in the demos and everything else to do. It says first gives you the first one, and then you go, is it not done? Okay, now you can use, and what you're essentially doing is you're using the very first time, you're using that one here. Then you increment. Then it's like, okay. And you're kind of looping through this, right? And this kind of feels wanky. But when you look at this, you have first, is done, and next. It really is screaming for a for loop. I know that sounds weird, but so the for loop here, you just set the first one to first, the last one next, and then you have your is done. And when I look at it from this interface, this is a lot cleaner and a little more protective, right? So let me kind of go through this.
Yeah, but doesn't first not reset?
No, it doesn't necessarily reset. It can, but the first is the first one of the iterator, right?
Yeah,
So
but if
just
your
saying for-
iterator's not been reset and you call that for loop after having, say, previously used the iterator for something, your current is in.
Oh, I see what you're saying. So is the first actually implied to have a reset in it?
And that's what I was having trouble finding online, because your stuff was assuming it did not, and
Right. I was assuming it was not there, buyer beware. But
and like to me, I actually, whenever I use it, I just take first out. And I only use current, next, and is done. And then you have to get the iterator again if you want to reset it, and that will always reset it, and that will give you the first one.
Mhm.
That's kind of what I was doing.
Right. And so this is a good discussion here, right? So from this standpoint here, I have all the cars, right? And if I go through this,
Like if you searched for, say, like Nexon, or not Nexon, that's the last one, but like whatever the second to last one is, then your first would be in a bad state for that for loop,
well, but this is designed to use as a collection, right? You're supposed to iterate through the collection.
Yeah, I was just gonna say like.
Yeah, but then
the
it
first
has to
doesn't
reset.
change. They're saying the first doesn't change while you're looping through it, while you're
Right.
accessing, right? It
Right.
doesn't.
No, it doesn't. But so your mode would be your mode is, then this should work. First of all, let me just show you first of all it working, and then we can butch it. But this is a discussion because this is a small nuance that actually isn't explicitly stated, right? But yet it has side effects, right? And so here we go. So the first one through, and boom, it just runs through the cars, right? And
Missing one.
I missed one. Yeah. All right. Well, let me see how the next one goes. Maybe my whole discussion is useless. I did this wrong.
It probably missed one because it tests is done when it has next. So when it gets to the last one, it never actually prints it because then it's done. It's at the end.
Right.
You have to do a do while or something of that nature.
No.
No, this looks like a mess up on my part.
But
So-
that's not related to the whole first and reusing iterators.
Yeah, no, that's not related
The
at all.
way-
That's related to this half.
Yeah, if you don't have a way to reset an iterator, you have to make a new iterator if you want to go through something
Right,
again.
yeah, but right now it's a brand new iterator. Bink, so we're using it.
Yeah,
So-
it becomes a problem when you take elements, like if you took the first off then you're gonna have a problem if you call first again.
Right,
ever.
but you should reset your iterator, right? Whether
Yeah.
that's first or a manual call to iterator, right? So anyway, architecturally I screwed this up, right? So A is
Actually, I think your is done is probably returning because you have the is done when next is null. Is that what you currently have is done set to?
right. I have,
So in this case, it would be you're only done once current is null.
so right here, my is done is
Well, it's just a Boolean, but
The Boolean,
if you
right.
scroll up,
right here. It's like if my,
that is wrong.
yeah, this is wrong, right? So it's essentially, so this gets into, so anyway, I think I screwed this up. So this is potentially, yeah. This
I don't
is,
think iterators ever support concurrent modification. That's
no, I think it's considered stationary when you iterate through it, that you're not like mutating as you're iterating.
That's where
Um,
I
there
had
was
a
a question in
problem.
the chat.
Yeah.
So, all right. So anyway, this is screwed up. This is totally wrong. So it still kind of gets back to the thing. So when we kind of look at this here, it does seem like this interface here is done. Is it supposed to tell you that you're done, that you read the last one, or is it done that you after you read the last one, right? Like when does this thing trigger, done? Is it that you just read the last one and it's done and there's no more to read? Or is it there's no more to enter in that's what,
Is there a standard for that, or is it just like preferable? You can do whatever you feel is best for you.
Well, the point would be there's a standard, I think.
Well,
Right, that's what I'm asking.
the problem right now is what I'm tripping into, and it seems like you guys are seeing some of the similar things. This is not well defined. This is really, the edge conditions and the true behavior is a little bit not defined as well as I would have hoped, right? So one of the things I've seen a lot of people switch to, and let's just look at and explore that, because I think this might solve all of our problems, is instead of doing is done, I love you can do this, has next, right? And boom, everything changes. And now has next, let's correct my logic. Has next should be opposite of none. All right. Test. Okay. And so now
Oh, you just have to change you invert it, right? You have to invert
oh
it
yeah,
there.
I had to
Yeah,
negate this exactly.
I thought you were gonna do it.
Yeah, good eye. All right. So yeah. So how do I'm in this trouble again. Last night I didn't know where to put this stupid little banner thing. So there's a control banner on anyway, let's get through this. All right, so here we go. So the first one should be A, because this is added to the end. Where right here.
It doesn't look like your change took.
You had it, you have to change
Yeah,
it
the
multiple
exclamation
places.
marks are still there. They reverted.
Oh, I must have undone it while I was doing.
Spamming Control Z does not always fix your problem, sadly.
There we go, neon. Yeah, so it's gonna go through this neon, so doing the whole thing. I still have the by one on the end, right? All right, so this feels a little bit better saying, does it have a next? Yes, use it. So the P first will throw out the first one, right? So then this has next should basically says there's no more material on the list, right? So where do you update the, has next or is done? Where do you update this field? So
I would use like PIT equal or PIT dot current equals null or something like that.
No, your
No, you
has
still-
next would be after you do your call to next. If there is nothing past it, then has next is true.
right. So that's what I thought I did, but clearly I didn't. So here,
And that's what your examples in like the original space, like the first ones you sent out, all
yeah,
of those have that net, because that's actually not what I would have thought for is done. Like to me, is done was the thing that I am currently on is null. Don't use it.
right.
Don't touch it. Don't do
this
anything with it.
this is really the future. The
But-
next would be past it,
You
right?
see, and I find that
that's what-
problematic because if something is set to null, then I might use it and it might, like that could be problematic to me.
And
Well,
then you
the
could, then you could
reasoning
think,
is you check is done first before you use it.
oh yeah, I was just gonna say, you could also consider it, that's what the problem lies, because is done can be considered to be like you're at the last element, you don't need to iterate again, right? So that's just too vague, right?
So here, let's just do this together real quickly. All right. So this is just a linked list, which is easy peasy, right? All right. So currently we're on this node, right? And so if this node exists, so if p link exists, we can access it. So we can go do this here. Yeah, that's fine. P link equals p link next. Okay. Oh, it doesn't like that term. So this just says, hey, I have something else, move it. Otherwise, it returns a null, right? Boom. Okay. So that gets us a little bit, right? But now we have to deal with the finished state, right? So if somebody passed in something here, this yeah. So this right here will always return a null if it hits the end of the list. Otherwise, it'll return the next, right? Is that suffice? Is that correct at that point?
Yeah.
Okay, so now we do with test, is it done, right? If it's done is now it's like, okay, we incremented it, right? So at this point, we're valid. So now we do this. We sit there and say, all right, if p link dot p next is equal to null, then
No, that's not
no.
necessarily right.
Okay.
Because if you just incremented off the end of your list, you can't use pinglink.pnext.
Yeah, null doesn't have.
So
a
what I was
boolean.
doing was you check plink again first, because you might have just hit the end. And then if it's still valid, then you check pnext. So if plink does not equal null and plink.next is null. Yeah.
Right. Then this is done. Right.
Yeah.
All right. So basically the is done is saying this is still valid on the very last time through it. This is valid, but it's saying the future one is invalid.
And that way, when you hit the top of the loop or even in a do while, it
It should
still
abort.
works correctly.
Right. Oops, not even close.
Can you
You've
cast
got
to
a
a
not.
null?
You gotta use the not again. Oh no.
No, don't, because we flipped it already.
So like
There's
if
the-
p-link were null, it's okay to cast it? That wouldn't be an error?
you can cast it because it's all the same type, right? It was
Okay.
born. So one of the things you can do with casting is if this is a D-link, right? And this is a car. And when it's born a car and you get everything, right? You get the whole stack. So car, P equals new car. Obviously, you can also do a D-link, S equals P. That's, you don't need a cast because it's in the hierarchy tree, right? If you have your car is born a car, but it's called a we'll call it T, new car, right? So this says I'm born a car, but I'm going to just call you myself a D-link. I can cast it down safely. Oops. I can cast it down, right? So this one's this is cast up. And that's allowed always because it's the hierarchy chain. This is why polymorphism works, right? Cast down, right, is dangerous. But because I know it's born a car, that's a safe casting. I'm allowed to do this cast because it's safe, because I know it was born a car. Its name happens to be D-link, and I'm just going to convert it back over to a car. Does that make sense?
Yep.
And that's the key. This only works, you can only downcast if you're guaranteed that I know it's a car, or I know what type of class is derived from it. And that is that's why our managers are monolithic. They all have the same type, so we can cast up and cast down with no problem. Right. So now let's go back to this code really quickly here. All right, so I'm coming in here, my current, I'm taking my current and I'm saying, okay, is my current not equal to null? Okay, cool, I can dereference it and return it. Cool. Otherwise, my current, if my current is a null, it's null at this stage right here. So right now at this moment right here, A, I have, the next it's pointing to, or B, it's pointing to null, right? So make sure it's not null. So we're checking this condition. Okay, now if it's not null, and then we can go to the next one. If the next one, A dot next points to null, then it is done. There's no more in the bucket, right? But when we did this just now, we're getting in trouble, right? We're totally getting in trouble. Oops. What button I just hit. All right, so boom. Okay, then it's stuck on civic.
Can you step into it?
All right, so this right now is current car. Oh, I didn't update the current car. Shit, sorry.
Oh, pcur is equal to pnex or plink.
Yeah,
That's
yeah, that was a mistake. All right. Yeah, there you go. All right, but it still didn't draw all of them out, right? So Kona is not the last one. E is the last one, which is Panda. So what's going on with the edge condition there? Has next, it says, do I have a next one? Yes, I do. I just drew the last one here, right?
actually, I don't think so.
Yeah,
Has next is
let me just move it back to is done. So we're talking back to the
yeah.
code, right? So is done, and it's not is done, right?
And then you'll have to change.
Oh shit!
You should just use the diagram. You have to change the,
Would have worked, except this time we would have had to put the bash in front of it, the inverse. Because now that we
No.
updated it,
no, because we didn't have the, it was still returning the opposite of be done,
Right. So,
but be done is wrong still.
I mean, it wasn't even
Yeah.
oh,
working.
it's still wrong. I thought we,
Wasn't,
No, be done is wrong. You're
Right.
returning backwards.
is done, right?
Yeah.
So it's done, right? This is negated the negate, right? We totally foobarred it now. All right. Oh, negate. Why didn't I take that? I think I'm editing while I'm debugging. That's my problem. There we go. All right, so again, we didn't finish it, right? So last step here, we're on Kona, and the is done is actually expired, right? So let's get down to that point.
And does this work for the while loop below?
No,
It should.
all right, let's take a look at it.
well, it won't
No.
because it's setting done when the next is null, like null. So then we'll set done when it's on the tail and it's not printing the tail.
Right, this should, I think, be moved to the up, right?
No, it's still after you increment, but it's like if p link itself is null, then you're done, and that's it. Not the p link next.
Yeah,
But I don't get how this works for like, I have something very similar to this and
I don't even
it
recall.
does print everything. Like, I don't,
it's very strange. It really is. Like I had, had something really ridiculous too.
There we go.
Yep, there you go.
and that's what I originally thought it was, but it doesn't pass the unit test if you do that.
This doesn't pass the unit test.
Yeah, you have
No,
to
I
say
don't
it's
think it's in.
done. Yeah, it doesn't. I had to do that. You had to say it's done when you're on the last element, and you have to say it's done when you're done as well, like when you're in the null for it to pass.
And that was what was confusing, because your unit test was testing it as you had there, but so if you put this though in a, I think my question on this is more, what does it mean for using cur, like in a loop as you would,
Current, my
like
understanding is
especially in a do while loop.
my understanding is current is that you can just beat the crap out of current all day and it should still keep returning it.
No, but so you hit next. And then the next one after that, oh, I guess that's fine.
Yeah.
It's sorry, if you use, so you have like in your loop, you're using next directly, right?
Right.
If you use next directly like that, where you have the return value on next and you're reading it, next may be totally invalid before you, unless you make sure you put it at the end of the loop. Like if you're using that to,
Yeah, but if you move next,
but then I guess you,
if you move next anywhere, buyer beware, right? If you do this,
Yeah.
buyer beware. Clearly you're not printing the first one, you're printing the one after that. But so this right here seems to be correct behavior, right? So anyway, these two are going there. My whole point here is I'm going to recheck my unit test to see if they're working right. But this is the whole idea, is that you should be able to walk all the way through this. It should sit there and not increment to the next one. It should be no hit to a null anywhere, right? We shouldn't be banking on it returning a null to exit or leave. We should be banking on this flag right here, right? The other question I think Robin brought up, which is does first reset or not, right? And from my perspective, I always think about when you're dealing with an iterator, right? So let's go back to STL iterators. When you sit there and say dot begin and not, in the end, right? So if you're doing STL iterator, this is begin and this is end, right? You can turn around and do it again and again and again and again, and it does reset it. So their first actually does reset this. Do you think that's the correct behavior, or should we kind of, I'm trying, what are we
To me,
doing to be consistent? It's all we
Didn't-
have to-
It makes
me-
sense that like first would be head. That's what I would expect. Like first should always give me the head.
But
Right, first gives you the head, but does first reset your current to the first one?
that's the question.
Hmm.
I would think no. I mean, I just used, my ability was literally just to walk back up my list, no matter where, so that I called it, I would know I would get like my most recent head, no matter what.
Yeah, but that's basically the same as calling reset. But my problem with that was when you use first like outside, like so when you create the iterator, you pass in the head pointer.
Right.
And
Well,
that's
yeah. Or the container that
but
holds
if
it.
you save that head pointer, you're not updating it unless you get a new iterator. Like and you get an iterator from the actual object that is being iterated over. That's the only object that knows what its head is. The iterator itself doesn't. When you save that pointer to garage, if somebody comes in and they delete everything out of the garage, then it doesn't like internal to the iterator unless you say, give me a new iterator with garage at the head here. How is iterator supposed to know where the garage's head is, you know?
And so to me, I kind of look at this as a constant do no harm iterator, right? It's not a self-destructive, it's not a mutable iteration, right? So here's a list of 100 items, and just sequentially walks through the 100 items. And you're not removing an item, you're not doing anything to the item, right? If you turn around and remove things from the list, I would think you should somehow either reset the list or call for a new iterator.
Yeah, but like first might be considered like just looking at the API name first. You
Mhm.
expect it to return you the head or like the first item in the pool.
Yeah.
And
That's
that
what I
Now,
could have
would-
granted, I
changed at
guess
some
I
point.
guess that means if there's like a change above, like okay, now you have to get a new iterator before you can call first or expect any
Yeah,
sort of
well,
state on it, if that's what you mean. I
yeah,
guess that makes sense.
that's how I was thinking, is that you would have to manually, you did
Like-
something to corrupt it, you should call either reset or just grab a new iterator from it.
Mhm.
At least that
That
was.
makes sense.
I
Yeah.
mean, that's
It's weird
depending
because
on you actually remembering to do that, though.
I really wanted
Well-
to mention, like I was doing something like that where I was removing elements through, like with the iterator, and I was resetting, and that was actually causing the problem of like getting a blue screen consistently. And when I didn't reset, it wasn't a problem. So it's only the problem if you remove the head, because then like that then they don't know what the head is unless you fix that.
And then I don't even want to open up the door, but saying an iterator for a partial list or partial poll, where you can sit there and say, here's my whole poll, but start from this point and iterate forward from there, right? That becomes yet another animal altogether. So would the first be the first of the whole collection, or the first where you reset it to, right? And with the reset, do you actually pass in the what you want as the head, right? So these open up a lot of design decisions that are all solvable, right? All solvable, but we just have to be consistent, right? So I will check to see, is my code's working this way? I think it should work this way. Is my code messed up?
I was gonna mention,
Um,
I recall that it was only on the Amazon iterator, but I could be wrong.
Okay,
It was doing the next,
so
or was it for all of them?
I just tested the garage iterator
Mhm.
without the like is next null is where your done is, and your stuff does expect it to be done when the next item is null.
Okay, so it was for all of them.
But that's actually that's consistent with the stuff you had in the first version of the iterator. That's like the same code you had. Is that code is what would pass the unit test. So the reference code would pass the unit test. It's just a question whether it's, and I'm trying to think what I did cause I did the timer with the priority queue. And I'm using this to insert it, and it inserts at the tail fine. It's like it does find the end and everything.
So like here is the this is the garage, right? Here's the test
Yeah.
I have right here. And the last one is E. The last one is
Mhm.
E. And I go through it, and I do next and okay, cool. And I get E, my current's E. I am done. There's no more after that. So this seems right.
It's not though. You need one more of is done is true when current is null.
Hmm. Why would why
That's
would
what
you
we just wrote.
that?
Yeah.
All right, let's
Yeah, I mean, I understand why you'd say is done is true when you're at the last element, because technically you are, but you're still done when you're on the null. So I mean, you could do it's like you could do it both ways, I suppose.
so right here, okay, let's do this. P iterator dot current dot print, right? So there's no, it's above table right now, right?
Mhm.
Right, so let's see. That's working fine.
Yeah.
All right. So the key here is this is fine. But now let's look at the source code here. I just did next. It can return an E, which is correct, the last guy, right?
Mhm.
My current return an E. That's correct also.
Yeah.
So I thought you said this was wrong.
It is. If you
Okay.
put the code, so I don't know if you have a solution in here or not, but
Yeah,
if you put the code that you just wrote in there, where if has like it's only
Well,
be
here,
done.
let's see. Do I have where the hell's car? All right, so let me really just hack and slash this away, right? Hold on a second. Shit. All right, so here's this. All right, and I'm going to add print to this. What the hell happened? What? Public void print. That's right, right?
Right line.
It's confused when you use what. All right. Now I'm going to make sure that builds right. Okay, cool. Now I'm going to cut and paste the stuff we're playing with. Wow, I have no idea why it's slow. All right. Iterate test. All right. I'm just going to cut and paste this. Go to, yeah. There's a-
You probably want that after two as well, the new iterator. Otherwise it'll be all screwed up when you go into the actual test part.
Oh, I don't care about the test part. I'm just proving
Oh,
it.
sorry,
Yeah.
never mind.
The test part has been working. So, all right. So here we go. So it did drop out. All right, so I do have that same problem then. So now let me go back and fix it. So I have a problem in my unit test then.
I think the whole point is when you are getting the next, without printing that you are checking is done is true. So that's why the last one is not printing out.
Yeah, I think you're right. Oh, all right. All right, so that worked. Okay, so now we're back to where it is. So now let's see how the unit tests work. Right, so now I just undid my print, right? And so now this is the original unit test. And it threw an exception, which is expected. So this one
It
is,
should be false. Because you're on the last one, but you've not yet advanced past the end.
I get it. You know what? I now I know where my mistake was. I'm thinking I'm already on E. Is done was set actually on D.
No. Your current is E,
The current is E. There's
and it was set
no,
in next.
And that's
When
the
you
last.
advanced from D to E, you set is done.
yeah. So at this point right here, I'm D, right?
Yeah,
And then
then you
it
hit next.
and then hit next and it returns E. So now
Yeah.
I'm currently on E, and there's nothing past E.
Correct.
So the iterator is done should be,
It's not done yet. You still have something in the iterator, I think is what it is. Like current is not null. Current still valid. Next might not be. But I think by convention, you have to check is done before you use the results of next. Is the only way it really works, and has is done make sense.
right. So that's
And that's the same for like, for has next, you'd have to check
Right.
has
So-
next before you call next.
so this should have been done there. So when I wrote the test, I should have wrote it that way.
Yeah, and then
Then-
after you call,
Next, then this next one should say is done is true then.
yes,
Okay, so it's the order that I wrote these unit tests that sent me down the wrong thing. All right, totally apologize, but I'll fix it and send off a correction. But I think this is important to get this right because we're gonna be using the iterators, a lot, and we need to just guarantee that they work, right? That makes
Wait,
sense.
Does
if
that
so,
mean
if
that
I
we should-
had, yeah, sorry, if I had all my tests passing though, do I have to redo it?
I'm going to do this. I'm going to leave the test as is, but you have a choice. I'm trying to think what's the easiest way to do this. This should be corrected, but I understand I gave you wrong unit tests, right? So so
This
here's what
is-
I'm gonna do. I'm gonna post out another PA. Was this PA2?
yeah,
I'll do PA2 _ take two, right? And I'm gonna grade PA the original one or PA take two, and I'll take the highest grade of either of those two. Does that make sense?
Mhm.
So this way, if you did it with the unit test I gave you, you'll get full credit. If you want to fix it, you can fix it, right? But it should be fixed moving forward. That's, I guess, where I'm going with it. So I totally got my testing edge backwards. So that's what
Since you're taking the higher of the two, we don't have to do the other one. for that.
don't have to do the other one, but I'm saying this though, moving forward, you should probably do it the better way, right?
this is used for the priority queue. So like, I know that I was using what was there and I was like getting confused on it. Cause it wasn't doing this.
Like, I still don't
But-
understand how this is even correct though, for me, but
Well,
So
it's correct, cause
because,
Which-
well, okay, because I'm looking, okay, you go to next, right? In current and then is done is false.
No,
then
no,
all you're doing in between is first, and why isn't done true is done true all of a sudden. I don't even get
It's
myself.
not.
which one here? No, just this is one state.
Oh,
Yeah.
oh,
So how
okay.
it,
All right, I think I
Yeah.
understand. You mean the
this is just
concept of
this
your check.
this right
Okay.
here is me doing it step by step instead of doing a for loop. Right. And
Yeah.
if you're doing a for loop, you would check done first, then you would increment, then you would use the current.
Yeah, and that makes sense.
All right. What I did in my unit test is I had done ladder. So now it's I had the loop kind of broken apart. So that was my
I mean,
mistake.
in mine, at the end, I checked if it was, I guess at the end I checked if it was, so to me, that didn't matter.
As these unit tests go, I have a mistake. Right. So let me, like I said, from a grade standpoint, it doesn't matter. You know, you'll get full credit if you did the original way or the corrected way, right? Either way. But moving forward, we want to adhere to this pattern, right? We really want this to work correctly. And between these two styles, right, where you do the while loop style or you do the for loop style, the for loop style is a little bit more terse, protected, and cleaner.
Can we actually test this with a do while loop just real quick?
To me, it doesn't
For
make sense,
curiosity.
but no, I mean, I understand you're saying it's done, like you're testing it before you're, but I don't see how that matters to me.
So
I just don't understand it.
first of all, I think a cleaner word is has next. I think that just seems to
Yeah.
be smarter vocabulary, right? The is done is, I think, already has a connotation, and the way they're doing it is a little bit different. It's saying, well, there's no more to do, right? Has next, I think, is much more appropriate. Okay, so you wanted to try a do loop, a do.
Yeah.
First of all, make sure this runs. I don't
I
have
don't know, just
clue
to
what-
like double check it.
I have no clue what my state is. All right, let's see. All right, so
Just
that's
curious,
cool.
but are we gonna discuss iteration over composites and components today?
Composites, yeah.
Okay,
Again,
thanks.
yeah. And basically what you're going to do, and that's why this is critical, we have to make sure we have this, our terminology and all the stuff correct, because then that might change the way we do the other, right?
Mhm.
All right, so here we're going to do a do, and then so a do should be, the first should be outside the do statement. Oh no, it can be actually in
It
it,
can
right?
be, no, you wouldn't put it in it because then it gets hit every loop.
Right, so I don't see how this is going to be much different than anything.
It should work if the logic is
Yeah.
correct.
You gotta experiment while coding, duh.
Okay, and then
Semicolon after the next.
thank you. So is that, God,
Yeah.
you haven't done a do while in years.
I think that's right. I'm not sure about the semicolon on the end of the wall.
Let's see. Fine. All right. Breakpoint. All right, and then boom. Yeah. Just feels wanky. Might as well put a go to. All right. All right, so okay, what I'm gonna do, I'm not gonna ever hurt you with grades, but I'm just gonna do this. I'm gonna go PA2, and then I'm gonna release tonight PA2 take 2 with corrected unit test, right? And what I'll do is I'll just grade whatever one gives you higher points you get. Okay, does that sound fair?
Mhm.
All right.
Sounds fair.
But I think, you know, just because there was confusion, obviously if I made a unit test mistake. This is kind of a thing, you know, to be aware of in the future. And personally, I think I like the word has next, because I think that's a little cleaner. And it communicates what the hell's going on instead of this is done thing.
Yeah, it's way better.
So do you think we should change it?
No, I'm just saying, just moving forward, this is just, remember these designs, as you see, our code's getting larger, more complicated. This is your own code base. If you want to use this name, you can use this name. If you want to use this done, you can use this done. You have freedom and latitude to do that. I just require that you use the pattern. Does that make sense?
Yeah, okay, so then standardized moving forward, it should be done when we're on the last one, not when we're null.
Right.
Okay.
It should print the whole collection
Right.
cleanly, right? That's just what I'm going with. I'm going to probably rework this weekend my code to use the word has next and to do for loops, because I think that looks a little cleaner. But today's work doesn't have that in there, obviously, because we just wrestled with it. All right, so I think that was a worthy discussion, even if you might not think so. I think it was worth it.
I figured out how my code is working in like the actual priority list. It's because when I wrote it, I hadn't looked at your code and I wrote it that way to start with. So it wasn't skipping the last one.
Okay, cool. So then you're okay. All right. So let's talk about composite, right? So the composite pattern, it's basically it's an OO way to do an arbitrary tree, right? And we went through this a little bit last week, but basically what you have is everything is a collection. I mean, here's a collection. Not collection. It's a composite. And if it's composite, it has one or more children. Right. And then if there's no children, that's a leaf. But if the child has children, you know, if it has children, it's also a composite. So here, right, and you can even have basically the whole idea is this is a collection, this is a single, right? That's the whole idea with a composite pattern. And so they have this kind of little bit winky thing, which is here's the component. Right, and then underneath this can be either a composite, right, which can own multiple components, or it can have a leaf, right? And the problem with this pattern from a real-time standpoint, wow, I'm gonna try one more time for a circle. All right, the problem with this pattern from real-time standpoint is that guy. It's right there. That's the problem. The problem is that you, how do people do a collection, right? So let's say this composite has 15 children, right? How do you represent that and hold that? And so that's kind of the cornerstone or the Achilles heel of this pattern. So, you know, when I look at this, I'm like, all right, well, I have a composite, and then I might have another composite. I'm trying to keep the colors same, composite, and another composite. Then this might have three leaves. This might have another one, and then this might then terminate, right? So these are all There's a composite, 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 and these are all leaf. Right? And so the question is, how do we convey a collection? So how do we kind of associate these associated to that guy? Or these is associated to that one? Or even simply, this is now associated to the guy above, right? And likewise,
Pile of linked lists.
right? And so this to me causes the mechanical problem, right? And this gets into kind of one of the big things about this class. To keep it real time, we got to think about growth and copying and memory usage and stuff like this. So in Java and in C# and everything else, you have these things, these arrays, right? And so you might sit there and create an array. So you just add the number 1 there, right? And then it's like going, okay, here's my array. And now I want to add the number 2 to it. So I want to add number 2 to it. It's like, oh, cool. Shit, we don't have space. So then it goes, okay, create one with 2 spaces, copy over the data and move it over to this. So here's the number 1. And now you can insert number 2 there. And when you do this, then this becomes marked for delete. Then it's like, cool, I want to add another number to this array. Like, shit, there's not enough space. It creates the space. Now it's going to copy over the data 1 and 2. And now you can actually insert the number 3 into that location.
Technically, doesn't it always double up? Like, it'll
No,
be 4
no,
spots.
no,
No?
Nope.
I thought Java was like that.
No, that's what you would think, but no, it doesn't work that way. So here's the catch. It grows at a very different ratio. It grows at 1.5 the floor of the previous number. So it grows very slowly. So when you're doing a push of 10 elements into an array, it grows 7 times or something like that, 6 or 7 times. So there's 6 or 7 news, copies, and frees. And all you did is added number 1 through 10 to an array, right? And this copying the memory, releasing the memory, and now obviously in managed languages, it's marked for release, so it could happen at a very bad time for you. This is causing us a lot of grief and trouble. And we're paying for, if you think about it, let's go even like a crazy, silly, stupid idea, right? Let's say you had, 1 million nodes, right? And it just happened to be filled, right? The whole thing's filled, and you want to add +1. And like, shit, now it's going to grow the whole thing out and then spend the time to copy all this over. Okay, now you can add your 1 to the bottom of it. Right now, obviously, when it starts getting bigger, it's not going to just add 1 million plus 1. It might be a million plus, 500 or 500,000 or something like that. It might grow at a pretty large rate, but it's copying a lot of data. It's allocating a lot of data. It's moving data all underneath the hood. You didn't even know it happened, right? So it's the old adage: you can't get something for nothing. You get the safety of a growable collection, but you don't get the, it costs you something. It costs you in memory. It costs you in copy. It costs you in marking more objects for garbage collection. And this is very expensive. So this is why in this class, we're not using arrays anywhere. Arrays cause trouble. So we're not going to use arrays from a performance standpoint. So this is why on the composite pattern, on the composites, we're going to basically start just jamming in, some kind of linked list here of items. And what's nice about that is you're only paying for the item you added. So if you're just adding, let's pretend for a second you're adding it to the end of the list. You're just paying for that one item to add to the list, right? Now, obviously for speed and efficiency, we tend to always add to the front of the list. If we want to add to the front or to the rear of the list, maybe we'll keep a head and a tail pointer into the manager. But adding one node should cost you order one on complexity. You should be able to anytime delete a node. So, that should be relatively lightweight as well. That's why we generally use double linked list. But if it's a really, really small and it's a super small linked list, say like the animation system, well, then we're only having 2, 3, 4 images. A single linked list is just as good there. You don't really need to go with the complexity of a double linked list, right? So this is kind of the key cornerstone here, is that we're adding our objects to a dynamic linked list instead of doing a collection. So if you look at some of the example code for the composite pattern, you'll see a lot of times, here's the children, right? And you'll see inside here, here's a dynamic list, right? So it's going to basically do a collection, and then that collection has all the problems associated with a collection, right? So we're not doing generics, we're not doing template-sized parameters, we're doing everything kind of mechanically ourselves, right? So here's the composite pattern in the code base. I did a quick sample of it. I think I have it here, and it's pretty straightforward. So here's the component. Here's leaf and composite. The composite has a linked list of head, and that head is more components, and it can just link through this to make this whole system work. What are we linking? We're actually linking components. So a lot of times what I like to do is sit there and do this and say, okay, let's just look at it from a, probably easier to this. Let's look at it from a composite point of view. There's a composite. It has a linked list of components, right? And ignore that. And this are these. This is what I wanted to show you here. So you basically have a composite that has a linked list of leaves or leaf. It's a singular. So there's a linked list of these, but these themselves can be other composites. So so from this standpoint, you could be linking another component, and that component underneath could be a composite itself, and that kind of gives you this hierarchy tree. So it's not that difficult. This is just basically an arbitrary tree that they did in OO. In some of my other classes, I created a different tree structure altogether because it's a tree. But I wanted to show you the OO kind of approach on this stuff here. So here's the here's composites. So I create a composite, grid column, this, and aliens. And what you do is once you create the composite, then you attach. So here I'm attaching 2 columns. And then each column I attach the respective aliens, and it's there. The printing was a discussion there, that the printing itself is kind of an interesting thing. It's iterative plus recursive. And here we're walking through the print. So in this case, right now, we're in the composite. The composite walks a linked list of components. The components can be either composite or leaf. So when it walks through this, it will print to the respective term. So if it's a leaf, it's going to jump over to leaf and do the print. But if it's a back here, if it's walking a composite, it's going to turn around and print this item's composite, which will then recursively call into this, right? And this is the standard kind of pattern that they're doing. They're using recursion in this pattern, right? So what we're going to do is start to linearize this, and so that we can actually use an iterator to walk through the composite pattern without necessarily going through the recursion. Now, right now, the composite pattern in the way we're using it is relatively small, but in real applications, it's data driven, and you don't know what kind of data is being thrown at it. So if you're doing neural nets, if you're doing larger systems, it's very easy to pop and blow your stack. And when you do that, it's a horrible hell that you're in when you blow up your stack. Also, it's very inefficient. You're pushing and popping a lot of state and variables between each of your recursive calls. So it's a little bit slower and can blow up your stack. So we generally don't like that for real-time systems. All right, so let's go to the code. All right, see where we're at with the code.
Professor, can I ask a quick question?
Mhm.
So something that kind of confused me is leaf always like a dead end state?
It's a dead end. There's nobody else underneath you.
So you could never, going forward, decide I wanted this leaf to have something attached to it. You would have to like remove it and turn it into a composite or something.
Yeah, this is not a dynamic, like the idea with this thing is that the structure when you create it, the layout of the tree when you create it, and then you can start to remove it. But if you have a leaf and you're going to say, I want to add something to this leaf, it's like, I can't add to it because I'm a leaf. So you have to, there's a little bit of planning ahead on this one.
Okay, thank you.
Yeah. All right, so last week we had the factory. All right. So this is the factory, and all right, and what we're doing here is we're having somebody else build our items for us and hand the result back. So here's just a factory. We can pass out arguments. Remember, this is a class. We can do a lot of things with this class. We can sit there and add variables into this class. So here's, a sprite batch. We can add a lot of different systems into this. It's a container. And what it's going to do is create the items for us, right? In this case here, it's being, the parameters are the type of the bird and the position. So here we have just create 28 of these, and they're all replicated. Now, underneath the hood, they're actually proxies, and proxies are all pointing to the same bird. So that's the whole concept of the factory. The factories allow us to create a lot of things on our behalf and kind of hide the complexity. So there's more parameters in here, or after you create it, what do you do with every time you create an object? Well, in our case here, once you create the object, you're going to attach it to the game object manager. So there's ownership. And then you're going to turn around and add it to a draw sprite batch. And what sprite batch are we doing? We pass that in the construction. So construction says, I want to use this sprite batch. So we pass that sprite batch into to this factory on construction. So here we can sit there and say the sprite batch we're using is Angry Birds. Now, every time we create one of these, it will add it to the Angry Birds sprite batch. So kind of the idea is that the factory, you can pass additional parameters, you can create your environment, you can hide more and more stuff behind the scene in the factory on our behalf, right?
So for the stuff that uses managers, like it's just going to be the items that are game objects effectively, right?
The game objects for the managers? No, well, we have managers on a lot of different pieces.
Yeah, but it's more pieces. It's not like we don't have a manager for the factories and everything like that,
No,
right?
no, we don't. No.
Okay.
No, those are one-offs. I mean, if you.
All right, so like the one-off stuff that gets created once and then used only really during the initialization, we're not doing that, or not doing managers for and stuff like that.
No, we're not doing that stuff.
Okay.
We can, but we're talking one allocation, right?
Yeah.
And then it's freed up here and we're not using this. What we're
Your
really worried
factories.
about, we're really worried about here is this part right here.
hmm
The
You don't want to be doing
we
allocations and stuff like that in
want
that.
to try to minimize as much allocations.
Okay.
The other thing here is if you notice, like when we create these objects, and this is from a couple weeks ago, this was a rectangle, and I in previous earlier versions, I said new rectangle, pass it in the rectangle, right? And then it's like it's created, it's held on the stack, it's used, and then it's marked for dead. And so to prevent this countless news being created, we're passing the parameters directly in, and that's going to reduce the kind of the overhead as well. All right, so now let's continue on. All right, so composite. So what we're going to do here is add a composite to the system. And this way we can start having some hierarchy and some order and construction. So last week, remember we had the game objects, which is what you move, right? So you move a game object around, it has an update, and you can have a draw and stuff like that. And then furthermore, I actually started to discretize it and saying we have a red bird, white bird, yellow bird, and then we have the factory, kind of thing here. And the reason why I did that is that moving forward, we're going to have different types of aliens, the squid, the crab, the octopus, and each one has different points, and it might have different behaviors. And so keeping them as separate classes here gives you that ability instead of just saying, okay, they're all alien, they're all aliens, and you have to start reading the parameters. Then you're have to sit there like, okay, well, what do I do with the points? And you're like, well, if it's a squid, give them 100 points. If it's an octopus, give them 50 points, and then suddenly you're trying to specialize the stuff. So we're going to start off with specializing the classes. It gives us a little more freedom in there. So here's the classes that we had from last week. And you can see right here is that a game object has a bird base, and this is just a general thing. And so if there's things that are in common to all the birds, the red bird, white bird, all these birds, I can push up into bird base and can keep uniqueness down here on the derived classes, right? So here's the bird base, and here I'm just telling you the type. There's not much here, but in the future we might have some stuff, right? I also introduced a concept of a null object, and the null object basically does nothing. So a real world example in null object is, like we had a factory in Mexico that I used to work at, and it would spray black paint on a conveyor belt and just be, here's your TV, and it goes, shh, and it sprays black paint onto it. And once in a while, so all these TVs will just kind of come through the machine and conveyor belt through, and then when it lands in the station, it gets sprayed black. And then it was really weird because I'm like, okay, well, that's kind of cool, I guess. What happens when there's a request saying, no, we don't want it spray painted black, we want to keep it natural wood? Well, the factory bot just says, hey, when it hits the station A, it's going to spray it with black paint. And the solution was so awesome. So here's the TVs that go by. And let's say this TV right here is supposed to be, natural wood, right? Well, automatically it always goes through the line. And all they did in the factory is they said, okay, we'll just put a piece of plastic box over it. So then when it went through the line, the plastic box got blasted, right? But the wood inside was clear. So they didn't sit there and say, stop spraying the paint. They just sat there and said, you know what, we'll just put a block over it. And this way it always sprays every single thing that's in front of it. Sometimes that box prevents it from actually hurting the wood. And that's a great analogy to a null object, is that you might have an object here. Let's say here's a sprite. And the sprite is going to have a method called draw. And in the function is like bloop, 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 it draws stuff, right? Well, if you sit there and say, okay, well, I'm going to have my sprite, base as an abstract method draw. And then you can have, we can have here a, a sprite, normal sprite, and, it does its thing. But over here, we can have a null sprite. And it still will have the draw function. This still will have the draw function, but it does nothing. And so this is a little bit strange. Like, why do we have, a draw function do nothing? Because then we just blindly call draw. It will go through here and do some real work. But if it's a null object, goes through and it would just call the function which does nothing and gets aborted. And the reason why this is a really attractive mini pattern is there's no special cases. If you think about the last code or last issue you tend to have bugs in, it's always on the edge conditions. It's always around the extreme where you're doing conditionals, looping edges, stuff like that. And by always saying, I always spray paint my TV, sometimes it does nothing to the TV, other times it sprays it black, but I always spray it every single time. That's kind of the idea with the null object. The null object is there, you can still call its methods, but the methods do no harm. And that's a really nice kind of item. So in our game objects, we're going to have some game objects that are null, right? And the null game object, what can you do there? The update does nothing, right? So now I'm like going, wait a minute, why do we have a game object that does nothing? That makes no sense, right? Well, what else is going to be attached to a game object? A game object can point to a sprite. So let's say you want, you want to put something on the screen, but you don't want it to move. You don't want it to score points. You just want it to draw some of the screen. You put it as a game object. It points to your graphical, picture on the screen, but it does nothing, right? But let's say the reverse. Let's say you want something to give you points, but you don't want to see it visually on the screen. Well, then you can do the same thing. You can put a sprite null object here. It can call something, and then it won't have to draw it. So this would be an example of, trying to think here. You want to move that UFO, or if you want to have a dancing guy on the screen moving around the screen, but he's not a player that you can shoot and get points off of. You might be just worried about this animation, the explosion, right? So the explosion might be dunk, and there's this little explosion. So we have, here's the alien, right? The missile comes up and hits it, right? But it really hits the collision box. The next frame, the guy is empty, right? So there's no, the guy gets deleted. The missiles hit, right? And then we start an explosion. So, here's an explosion, right? And that explosion is there. So this is a game object. It has, we can place it in the screen, we can rotate it, we can move it, we can do everything we want of it, but it has no points. It doesn't rotate, it doesn't move, it does anything, it just draws it there, and then the timer later deletes it. And it kind of removes it. So we're going to have this whole concept of a game object. The game object is what we control, right? Then hanging off the game object is going to be some type of sprite, right? And we'll start talking about this today. And then some type of collision object, right? And so all your movement, keyboard presses, everything is moving game objects. And then game objects will draw and can have collision. But if you don't want a sprite there, you can just have a game object that has, just the collision box, the collision system here, right? And then it could just have a null sprite. And vice versa, like your high score table, your high score letters will have a sprite, but won't have a collision because you're not shooting and hitting the high score. So this is kind of the idea of a null object, is to have a surrogate object in there that you can add and remove, right? All right, so let's go back to this. So here's our game. Our game object, remember, our game object node manager is very unique because it holds game objects, right? It holds a node, and node is just a pointer to a game object. The reason why this does this is that this is heterogeneous, right? Since we have many different types of games objects, we have birds, we have aliens, we have shields, we have UFOs, we have the ship. They all have different number of data fields, different behaviors, and all that other stuff. We're just going to hold the one pointer to it. So the manager over here is just holding pointers. So it's a collection holder, right? Which is different than the image or sprite manager, where they actually create and manage sprites. This just holds a game object. So we're going to have our factory create our game objects externally, and then we associate it to the game object node. Okay. So now let's get to the add a proxy. So here's, a proxy, the composite. So here's the component, right? And we'll have a composite in the leaf, right? And show you how we started off. So we create the animals, boom, 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 boom. So, here's just a small factory that creates, 4 game objects. I create a composite, and I'm going to call it the grid. And I'm going to say grid, add these 4 objects, right? And I'll just print them the grid, right? So and so here it is, the composite has yellow bird, white bird, red bird, green bird. Now, I don't care what order these are in, because they're all, from my perspective, they're all associated to the grid node, right? So I have that here. So, this just now starting to add a little bit of structure and a little bit of organization. So where does this work in the whole grand scheme of things? So on the composite pattern, we have right here, we have the leaf, composite, and then we have component. And so, all right, the leaf, is just the birds. So yellow bird, red bird, all this sort of stuff. Or it can be, game object null. But the composite, what I'm doing here is I'm reusing the D-link manager. Saying, okay, well, the composite just has a D-link manager. Why D-link and not S-link? The D-link manager, obviously we have it done already, but the reason why the D-link is then I can remove it very easily. I can remove a node because it's double linked list. I don't have to walk through a node to see who's the previous node. So it's just, simplifies it a little bit. All right, so, and then what I'm going to be adding is components, right? So I'm adding components. So the component here, this game object here, I can put anywhere, right? I can sit there and put this game object above this component or after this component. It felt a little more natural leaving it as a derived object. And the reason for that is composites add components. So therefore, it also encompasses all the behavior of a game object from a casting standpoint. We could have swapped it around, and I could sit there and say composites add game objects. What I didn't want to do is composite add component, and these two are swapped, and then I have to upcast to kind of get to the game object every single time. Like I said, these can go in either way. There's arguments for both, but I think it feels a little more natural there. All right, so component, I basically create some contracts, add, remove, and print. Again, this is recursive at the moment. Diagram. The component just derives from the game object just derives from component. That's pretty straightforward. The leaf now has to do those contracts. So here's the override, add, remove, and print. And I'm just sitting there stubbing it out. And then the composite now has hanging off of it a node to a D-link. And there we can sit there and add to the front and then remove a node from this right from the list. And all that information is reused from our previous system. All right, so create for birds, create a composite, add them, right? There's not much more going on at this stage than that. Right. So now let's go a little further. What if we wanted to put them into a column? And please remember, all the source code that I'm giving you and demonstrating here is just proof of concept. It's something I bang together quickly to kind of get to, some show and tell, right? It definitely needs a lot of cleanup and some rework. So here's the column. And so I'm doing create a bird. Each bird has 3 columns, and then I put 4 birds in each column, right? And so what I have here is this. This is the grid. And then I have column, column, column. Then I have birds. Right. And the idea is that you would have your birds. Right. And then this would be your column. And then this will be your grid. Right. So, all right, so I create a grid. I create 3 columns. I add that column. I'm going to add the bird, and I'm just basically nesting the factory inside it. The factory will return the game object. So, all right, so I add 4, then add 4, then add 4. So I create these birds up front. Then I create the grid, the columns. I add the birds to the column, add the birds to column B, add the birds to column C, then add the columns to the grid. And then I print. And the printing is, pain in the butt, but it really helps in the end, right? Because now I can walk through and like, I got yellow bird, white bird, red bird, green bird, new column, those birds, new column, 4 more birds. Now I still do the attachment. So I still created the factory. I still gave it a factory name. I still attach it. So these will be drawn. And the reason I'm just using these birds is, just managing these different aliens. Right. So now the next thing is let's move them. Right. So the first way we're going to move this is I would call it the brute force way to move this, which is we're going to use the composite pattern, and we have a abstract method called move, and that's going to be in every leaf and every composite. So look here, composite pattern. And again, I can't emphasize to do the drawings more and more because you can do a lot with them. So here's the move. And now the move is abstract. So now somebody has to implement this downstream. So this move here, here's the game object. There's no move, right? So here's the leaf, there's no move. But when we go all the way down here to a bird, there's the move. And if you missed the move, right, for some reason you just didn't implement it, it's going to basically yell at you and saying, hey, you didn't implement it. It's kind of nice, right? So it's going to remind you that there was a contract somewhere upstream that you're missing. Right? So basically, as we navigate through this mess, the leaf, every node here has a move. By calling move on the composite, everything kind of goes in here. The second thing is, remember, collections are composites, singles are leaves. So here's the leaf. Underneath it is a single bird, right? Under a composite is a collection. So under a composite is a grid object or a column object. So here's a grid or a column. And then each one of these obviously still has the linked list, the linked list manager. And so there's many collections of those. So now I create the factory, create the grid, create the columns, attach all the birds to the grid. Cool. Then here I'm going to just basically find the grid. So I'm just running the game kind of free form. I'm going to say, hey, go to the object manager, find the name grid. It returns me a pointer to it. I'm just going to call grid.move and pass in a delta, right? And I just move everybody in that thing. Now this is going to recursively call through that list.
Just to confirm, is the grid the root node and then the columns the composite nodes? Okay.
No, the grid is also a composite. So,
Right, but sorry, in the code, P grid, does that hold all of the other ones that you named, column A, column B?
yeah, this right here, this is the P grid.
Mm-hmm.
So that's the P grid, right? And this is the column, right? And so if you look at it from this perspective, this is a composite, this is a composite, this is a composite, this is a composite.
Right, they're all composites, but grid is the root node in the code and here, right?
Yeah, well,
Okay.
mimicking the graphic.
Okay, thanks.
Yeah, so you see right here, the grid is right here. This is, we're creating a new bird grid. And then we're attaching. So we're here, we're going, we create a column, we attach birds to a column, create another column, attach birds to the column.
Thank you. It's
And
because the
then-
scrolling was so fast, I didn't catch the attach part at the very top. I see now.
Oh, this right here, this line of code can be anywhere. This is the one anchor to the whole. If I don't have this in here, it's not associated. There's no ownership right now.
Okay.
So so that can be anywhere in that. Right. And so in this case here, no, I know how to suppress this. I've done it before. I have to figure out how to suppress this little window. So here we go. We have this whole thing moving back and forth, right? And I'm just, hard setting where it moves so far, and then when it hits a certain number, turn around, moves so far. There's no collision. It's just mathematically, I kept noodling with it until it looked right. But all I'm doing is sending one move command. I'm just sending one move command. And now that move command is on the grid. So it's on the highest node. So it's on the highest node here, the green. And what it's going to do, it goes into this, and it's like, okay, so it's at the component. So now we really need to look at the tree. It starts from here, and then it goes, okay, I have to go to the composite. It goes to the composite. The composite says move. Cool. Now I get the iterator, the first, walk through the linked list, ding, 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 ding. And I'm going to call move on each node on that list. So the node on the list would be, the first node would be a composite. So it'd be column 0. So turn around, it goes now into a composite. Now it goes in here, its move, which is a recursion, but I wanted to see go back into this. Now it's column 1. It goes, okay, column 1, get the iterator to column, comes for column 0, get the first, iterate through it. And it says, okay, the first node, which is the first bird on column 0. So now it's going to call move on that. So it goes in to this, and then now, depending on what's hooked up to it, maybe the first bird is, the green bird. It goes green bird, move, and it adds the offset. Then it goes back to the composite, move, next, it loops back through, and now goes to the second bird. And the second bird is red, and it goes to its move and moves it. It goes back to the composite. Next, goes to the next bird, move, and it will go to the white bird. And you get the drill. It keeps doing it. And then when it's all done with that, it's going to, so it finished, and it just drew all of the bottom ones here. Then it's going to turn around, go to the next one, and start doing those. And then the next one, and start doing those. So we'll do it through each of those collections. All right, so this is moving this, and it's using recursion, right? Can we do better? Can we deal with this? So one of the things here in this component right now, it just has move. So, and if you have some, please, oh, thank you. I can't see the chat easily, so make sure you scream it if it's important.
Just mentioned how to turn off the that console because it's still bugging you.
Yeah,
I found out how to do it.
It totally bugs me. All right, so we'll turn it off in this next code base, and then you walk me through it. Right, iterator. So so we can make an iterator on anything, right? Data that is weirdly formed. If you remember the Amazon trucks, it doesn't have to be even linear. We can put iterators on anything. All right, so first of all, we just run this. Okay, cool. All right, so now we go into what, tools, options. What was the?
Sorry, and yep, you got that, and then
it's
project properties.
Yes, that's right.
And then
That's,
linker.
I totally remember this now.
Yeah.
Yeah. Project.
Okay. It might be different here. Okay. All right. It just doesn't look the same thing. Okay, I'm sorry.
Yeah, I think what you just described was C++.
That's C++. I thought it was the same. Okay. You know what?
That's C++.
Yeah.
Yeah. Okay.
There's no
Never
link
mind.
here.
We'll
absolutely
figure out
no
at a later
link.
point. Yeah, I'm like going, I think that's C++. All right. All right. So we're doing iterator here. So let's go to composite pattern. All right. So here's the iterator base. Next is done first, current, right? And to make life doable, turns out it'd be really nice to know who's my parent, who's this stuff. So let's break down the problem a little bit simpler. Let's just say we have this root, column. Let's just say, oops, alien, 1, 2, 3, 4, column 0, column 1, and then root. Okay, so let's say that that's our pattern, right? And if you're currently sitting inside an alien, right? Who's its parent? The problem is our pointers do not look like this. Our pointers kind of really look like this. Here's the root. And then we really have hanging off the root we have column 0, column 1, right? Then off of column 1, we have alien 1, and then alien 2. And then off of column 2, we have 3 and 4, right? So it turns out if we want to start walking this list, we think about it, you start from here. It's like, okay, print this, forward iterator. Go to this one and this one. Okay, that's easy. No, that's easy. Go down to here, go down to here. But now you're sitting in this node, right, with no history. But you have to come back to this to go to its next column. Right? So it's useful. So we really only have, even though conceptually it looks like this, we really have, our pattern looks more like root, and then we have C0, C1, and we have.
No, doesn't root point to C1?
Are you talking about push to front, push to?
Oh, no, sorry, never mind.
Yeah, I'm just saying, assuming
You're talking about the linked lists and
yeah. And so then this points to alien 1, and then alien 2. And then this points to alien 3, and then alien 4. But we have no history. So if we're stuck here on alien 2, right, and that's the current one we're on, how do we know that we're actually supposed to go up to C1? If this is our current state, right? So it'd be useful to kind of go back up to its parent, then we go, oh, parent, well, there's a next here. We can go to this one, and then we now can handle C1. And then, oh, we're on C1. I'll go down as child, it's the connections, and then go to 3 and this, that. So basically, we're doing it at depth first kind of pattern. Well, to make this work, we really need some helper here. And the helper we need, did I not click the right one? Yeah, the helper is we really need to know the parent. So what I did is I just defined the parent here. Here's the parent. And then anytime you add somebody, so when you add a composite, I'm going to say, hey, I'm adding this component. So the parent is the composite. So we're adding it to, it's parent add a child, right? This is parent add a child. So I'm going to say child, here's your parent. It's this. So this is where I hook it up. So I have a back pointer for this. And now with this scheme, I have a lot more data. I have root, column. Then I have my aliens. And now I have, everybody has a parent pointer. So I can always walk my linked list, here is the, this down here. So if we follow this, so let's try to follow this. So I'm at this node here, I go to the head, I go to the next, I can get there. But now I can go back and I can go to the next and then go to this one. Then I can say, oh, let's follow the head here. Now go to next, I can get there. So I can now start walking this just by having that critical back pointer. And the cost is adding one pointer, which is like nothing. So I added the pointer to this. So now when so everything's kind of the same. I can move stuff around and do stuff this, but now I can start doing the iterator. So here's the iterator. And I have my 4 terms there. And now I have to go back and make sure I did this correctly, but I think I did. All right, so what I have here is next. I basically create the concept of all my neighbors next to me. And by having this, I know my whole lay of the land. So what I essentially say is, okay, given a node, given any node, right? I know who's my sibling, who's the next child at this level. I know if I have a child, and I can find my parent. And when I have these 3 boxes, sometimes they're going to be null. It tells me how I can walk around this tree. So now, just by adding that abstraction, now I have these 3 guys. Now it becomes pretty simple to kind of walk my way through this. So given any node, do I have a child? Go to get child. And I go, okay, get child. And I'm just like going, if I'm a composite type, I can get the head. And otherwise, it's a null. So what I did here is I added a type. And this type, this is at the component level. I just create a enumeration leaf for composite. And I just sit there and say, hey, what type are you? Leaf for a composite. And so I'm either a leaf node or a composite node. So I found that I needed that information, without using reflection, right? So it's like poor man's reflection. Right. So so there is, I just they're saying, am I, given a node, am I composite? Yes. Give me the head, that's the child. If I'm not a composite, that means I'm a leaf node. That means I have no children. By definition, a leaf has no children. Right. There you go. All right. So sibling, right? So sibling is it's real simple. Go to the next, right? Let's go to my next node, right? So I'm just going to go sit there and say, okay, do I have what's my next? My next is going to be null, or it's going to be pointing to a real sibling, right? The reason why I'm allowed to do that is because it's a D-link, and the D-link component, oops, yeah, here, D-link here, the D-link has the next and previous. So this is the next and previous, this next and previous used in the composite, and the composite D-link manager has the next and previous. That's why I can get away with that. All right. And then my parent is simply that pointer I just created, because that was the secret sauce to make it work. So let's return the pointer parent. This will be null if I'm at the root. Otherwise, it'll be pointing to the one just above me. Okay. So now that I have all these, now I said, given one node, where do I go next, right? Where's my next move? So I just abstracted it to a next step. And so basically, given my current situation, where do I go next? I'm doing a top-down iterative walking of the tree, right? So I'm doing a depth first walk. So if I have a child, that's my next step. I always walk down into the child and then return that. So I return, boom, child. If I have a sibling and I don't have a child, then I'm saying, okay, go to my sibling, right? Then it gets ugly, right? This part here, right? So I'm currently on a node. I have no siblings. I have no children. I need to go up to the parent. So while the parent's not null, then I say go to the, so the parent's not null. So I pass in the parent, cool, it's not null. So now I go up to the parent, and I mean, the parent's not null, so I have a parent, cool. So now I'm at the parent level. I said, hey, parent, give me your sibling. So that would get there. If I found it, great, I'm done. I found the next one. Otherwise, I don't have one. Go up to get the next parent. So parent get parent, and this is basically just going to bump up a level, right? And this will return the next null, or I mean the next node in the linked list, and the next node in the tree walking and this is an iterative approach. So kind of give you the crappy scenario, right? You always have to kind of think about the crappy scenario. All right. So
Does that get like parent is equal to its parent, get the next parent, and if it's still not, is that
Yeah.
a loop?
yeah, it's a while loop.
Okay.
Yeah. So here, this is how it works. So let's say here I go to this one, boom, right? And I go down, then I go down, then I, remember, always bites down. Then I go hit the first child. Cool. There's no more children. Go to my sibling. No more children. Go to my sibling. No more children. Here's where the crap state starts, right? So now I have no more children, right? I'm at this node. Go up to the parent. This parent doesn't have a sibling. So do nothing. Go back up. This one has a sibling. Cool. Go to this sibling. Next, go down. There's nobody. Go over. Nobody. Okay. Next time, go up. Here, it has a sibling. Cool. Go to the sibling. Go down. Go over. It doesn't have any more. Go up. This doesn't have a sibling. It doesn't have a thing. Terminate. So that's when it would end. So this will allow you to do depth first walking in an iterative form. Right. And I found that the logic cleaned up hugely. I mean, my code before was just spaghetti ahoy. Once I decided, like, what if I just got all my neighbors and I reduced the problem, like just I can find a child, I can find my next sibling, I can find my parent. And once I had those three, then this next one was very easy to write. And here's the, okay, I'm at no siblings, no children, go up to a parent. No siblings, no children, go up a parent, go up a parent. Okay, found somebody. I like that, go fish. All right. So what does that do? So let's take a look at this. This is probably the way I think is the right way to move your item, your object around, is using this iterative approach, right? So I drew this whole thing out, and what I did here is I sit there and say, okay, there is 2 columns. Each column has 4 children, right? So then I'm going to just now print this out. So I'm just going to do a print using the iterator. And what we got here is bird grid. Then we go to the column. Then we go to the 4 birds. Then we're going to go to the next column. Then we do the 4 birds. And so I was able to iterate on all this stuff here. So now, instead of doing this move this way, you know, kind of the thing I can do now is this, and then it'd be node move. Okay. And it's just going to run right off the page, but we'll see it work in theory. That's it. And what's nice about that approach is there's no recursion. Right. So let me take this. So you can see, you know, I'm just moving it across there and I'm just iterating through this, and you look at this iteration, it's going to hit every single node there and do its work. And that's better than doing that recursive call. Questions so far? All right, let's keep going. All right, so now the next thing is to start adding the collision system. And the whole reason why we're having the collision system is, okay, imagine you have lots and lots of aliens, right? I'm not going to draw them all there, but let's pretend you have a lot of them. Right? Now you have a missile at the bottom going up, right? And in this case here, I drew 5 times 4, I drew 20. So I have to do 20 compares, right? 20, you know, missile versus first one, missile versus that second one, right? And in reality, we have 55 aliens. So there's a lot of things to check. What I can do is sit there and say, okay, well, they're in columns. And so now if I just check it against the 5 columns, I just have to do 5 tests, five checks, right? Where I'm like, well, you know what? If it misses the whole stinking grid, I only have to do 1 check. So 1 check, I miss everything, right? And so if I do 1 check, I'm like, and the missile keeps on going by, hey, guess what? I don't have to check anything else. If it hits this somewhere, let's say it hits, you know, here, right? It's okay, I did the 1 check. Now I go down to the next level of the hierarchy. I'm going to check the columns. So there I do the 5, and it hits on the second column. So after I could have done 5, but I only did 2 of them, and then the second one it hits. Now I go in here and compare against the 4 aliens, and I find it hits this guy. So now I go from 1, 2, 3, 7 compares instead of all 20. And you think this is like, you know, not a big thing, but you know, what we're essentially doing is doing this. Right, so this is just your aliens. But in our game, we're going to have shields. You know, and the shield's going to have, you know, 12 columns, you know, 10 bricks. So there's 120 right there, 120 120, 120. Then you have the alien grid, right, with the columns, you know, and then the individual aliens, right? And so there's, you know, 55 of those, right? And then you have, you know, the wall, you know, all this other stuff. But by just putting the hierarchy, instead of doing 120, 120, 120, 120, 55, you know, we're doing one missile versus, you know, 55 of these, you know, not 55, you know, roughly, you know, 500, 600 of these just for a missile. Well, then your aliens drop little zigzag bombs that drop. Now the zigzag bombs have to check all 120 in the floor. You know, you get, so there's a lot of things we're doing, but just by putting into a hierarchy, we can abort and skip a lot of unnecessary collisions, right? And this is another way that we can use the composite pattern. All right, so before I go into this next part here, because we're getting into the collision system, I want to just kind of give a commercial break to tell you what we're doing for our milestone. All right. So this is the milestone. And there you go. So this week right now you're working on sprint number 4, I think. Is that right?
Yeah,
Yeah.
Okay.
sprint 4.
Okay, so then the following week, this is due, and I'm going to release this tonight. This is the milestone. How do you make this full screen?
Zoom in.
No. I have no idea. I don't like this banner and all this other crap here. Oh well.
F11 or F12 maybe.
Nope. All right. Clearly I don't know how to use do it in Firefox. Full screen. There. All right. So so here's the thing. You know, did you cheat? Yes or no? Blah blah. And you're going to basically, in this first pattern, the goal is to make I hate this, sorry, I'm gonna have to go back. I don't know how to get there.
It's just
Hit
F11.
F11 again.
Of course, yeah, that makes sense. I have hit that stage in my life where I don't know how to use tools. All right. All right, so here's the catch. We're gonna be using all these patterns in demo. Singleton we used before, factory, object pulling, all this other stuff. And then your goal is to make the aliens, right? And what we're going to do is literally do it a screen correct size, screen correct proportionalities. We'll start at
Control L.
What?
We're seeing Control L.
Control L.
That will make it full screen.
You are awesome. All right. I don't even know how you figured that out, but cool. All right. So so what we're going to have is the full we're going to do the full screen, and your alien's going to be either white or green. And you're going to do, you know, 1 row of squids, 2 rows of crabs, 2 rows of octopus or octopodies. And your guys have to move in lockstep animation, right? So here's what it's going to look like. All right, so just imagine these guys are moving all step for step, not staggered, but all lockstep, so they all jump and jack at the same time over in just a grid back and forth. That's all you're doing. but it needs to be proportionally correct. These have to be similar size to what it is on the screen. We'll start some threads on this to talk about the size and the resolution of your screen, and the screen is black and your guys are white or green. And so what you're basically going to do is start to get this game kind of up and going, right? They'll be moving back and forth. The movement has to be controlled by the timer. So it's move, step, and they change animation, step and animation. They shouldn't be drifting and moving at the same time. They should be lockstep. So if you look at the video, you'll see that they're moving step for step for step on this, right? All right, so inside of here, this becomes like a laundry list of a lot of little systems, right? So I want you to talk in 30 seconds or less about your Sprite Box Manager. How are you using the singleton and how it's constructed and used? Then talk about the factory, how you're using it to create aliens. And you're going to literally open the code and show me that part of it. So your video capture is going to be literally watching the game run. So, here's the thing, the grid of 55 aliens and proportionally things are moving lockstep, where I go junk, 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 no noise, but there'll be animating step by step by step back and forth across the screen, right? How do you get it to stop from one end to another end? You can hard set that. I don't really care. We're going to be starting to go through collisions to show you how to do it with the collision approach, but it's not required for this stage. 55 aliens, move it there, the video's there. And what you're going to do is you're going to show off your code by showing some of the code. So here's kind of an example. You would show off your Sprite Manager. So 20 to 30 seconds, don't spend more. Show the little bit UML that you have. The UML that's in Visual Studio is fine, like what I've been showing you. And show the UML, then go around and turn around and show the mechanics and go in there and show a couple lines of code that's the critical part of the manager. Prove to me that you know what you're doing. You don't have to show me every little stroke, but if you skip an area or if you arm wave it, it's a 0 on that part of it, right? And you're going to show every single pattern. Then wherever you call new in your game, anywhere you're call new in your game, you're just going to put a comment field above it or next to it, and it's LTN or STN, short-term news or long-term news. And this is why, like right here is a node base, right? I put there long-term new because it's going to be part of the manager, right? And then the short-term news, like here's the factory. We're only using it to create the objects, and then it goes away. We're never using it again. So every single new, you're going to, just define it as you're looking at your code as long-term or short-term. Just a quick little comment next to it. It should try to use as much of the object pooling as possible. You want to reuse the things. You don't want to sit there and keep creating new aliens and new characters every single frame. You want to keep reusing those guys that are there. So the whole goal is while the game is running, you're trying to stop it. So you have to prove that your object pooling is working, show that you're using the managers correctly with this stuff. Then you're going to basically go through each of these patterns. So click in the boxes like I finished these. You should have them all finished, but then every one you clicked, you have to show it off in your code for 20 to 30 seconds, right? This task takes a little bit. I mean, it's like we have it all there. There's nothing new being added. You're done at this point. You can use this stuff. The adapter we've used with showing the texture class. There's gonna be sections in your code where you might need a null object to show off where it is. Composite template we're using, iterators we're using, command patterns we're using, proxies. So we have everything here. We're using this. The priority queue show that it's inserted in priority order and that you're early and out when instead of walking the whole linked list, right? And then that you're prove that the pooling's working and litter your code with the right LTN or STNs and the Y behind it. So LTNs, you place the order owner, and the short terms, you say why it's a short term. Okay, that's it. That's the first milestone. This milestone is worth pretty big points. I think this is like 20%. The
So we don't need a design documentation for the milestone, like it said in the syllabus.
I thought I was going to do that, but let's see. Normally I have you do one. Oh, I know what it is. I have you do a design doc, one pattern, and it's not graded. I give you feedback. So I will add that as an aside, but it's more to have you do one pattern so I can give you some feedback on it.
And quick double check, just make sure I didn't miss anything. Proxy has not actually been in one of the sprints yet, right?
Proxies have been in a lot of sprints. Oh, in the sprint? Well,
Yeah.
you should be using it. We've been using it for at least 1 or 2 weeks now, right? Yeah. How do I repeat those those aliens multiple times? It was in a
Was it
PA.
the factory? So I think just in the last week we had it.
Yeah,
It
we-
wasn't in the PDF for the
No,
sprint
it wasn't
batch.
it wasn't in the PDF.
Okay, yeah,
Yeah.
all right, I'll get those added, yeah.
Yeah, it's the reason there is you don't want full deep heavy sprites in there when you can get away with proxies.
Yeah,
we-
I was going off the PDF, so I hadn't added them yet, but then I saw they weren't in Sprint 4 either, and I was like, "Oh, I wonder if those were supposed to be in there already."
Yeah, well, we have it, I think, in last.
Yeah, we covered it in that stuff.
Yeah.
I was like going through the PDF to do the sprint.
Yeah. So we're using there. I just assume we talked about it's in there,
All right,
but
Can you give us an
yeah,
example of
it's
when
not a
we
big
would use a null object.
yes, you're gonna find needs for the null. It's in there right now.
I know we have it implemented, but I don't think I've seen an
null-
example of it being used yet, but okay.
And the null object is literally a dummy object, right? There's nothing you have your method, right? And you do the draw or you do nothing. All right, so here. So your comparison object is using a null object.
Oh, okay.
Or well, sprites. Let's go sprites. Sprites. It'll come there. It's right now. All right, let's stay tuned with that. I might modify that. It should be. I know we're starting to use it. If not, it's coming.
Thank you.
It will come. Yeah. All right. It's a nothing burger. When you see how it's used, you're like, really? That's it. All right. So let me close some of these things out and we can start the next section. So this is just, I want to get you guys, the 2-week warning is fired off, right? So it's not due this Sunday, it's due the following Sunday. And this is the big immutable thing. All right. Week 6. All right. So collision object, right? So here's the collision objects. And what we're going to do now with the collision object is start to add collisions, right? And collisions are basically, we always collide against boxes. We don't collide against the graphical image, we collide against a box. And that's why we have the box sprite in the first place, is to kind of give us a visualization of the boxes. So here's our collision. So let's say collision. So collision object just has a box sprite and a rectangle, right? So so here's a collision object. And all it's going to have is, oh, this is what we collide against. We collide against a rectangle, which has the, the collision rectangle, which base class, there we go. X, Y, height and width. And we also have a collision sprite. So this is your sprite. Right, so this is pretty much the collision object. It just has the X, Y, and height and width. And it also has a box sprite that we draw. That's all it is. And then on the game object, it points to the collision object. So now we have this. So this is kind of the lay of the land. Right, so a game object is what we move around. We move the X and Y on the game object. It might have methods called update, points, and play sound and stuff like that. And then whenever we move it, this movement, when we call update, this update will copy to the proxy. So it's going to copy our XY to the proxy. And then our XY is sitting in the proxy. Then our proxy, when it's being rendered, pushes a deep push, pushes the XY into the full featured sprite, and then this gets drawn, right? The collision side, game objects move around, right? And it points to a collision object. The collision object has a rectangle, that's what it really collides against, and a way to display it, which is the box, sprite box or sprite box proxy. So we can draw the box, right? So here's the on the game object, right? So we have the game object. The game object has down here a pointer to the collision object, right? So it's just this diagram points to the collision object. And if we don't want a collision object, we put a null collision object there, and then we don't get anything. If we want a collision, but we don't want a graphic, we put a null sprite proxy here, right? So this is where we start using the nulls. Let's look at this a little deeper. So when we create this, we again lean on our factory.
Sorry, you said when we want a collision, but we don't want a what?
So sometimes you're going to want, think about a game you play on your phone, right? Sometimes you want a graphical element on the screen and it collides and makes points, right? Sometimes you want a graphical object that spins in the corner, but you can't shoot it, right? It's just there for prettiness.
Mm-hmm.
So if you don't want it to collide, you just put a null object there. If you want it to collide, you put a real graphics object. So basically here you swap this with a, I don't have it yet, but you'll put this as a null. If you don't want this, don't worry about the null part right now. Don't get confused yet about this. Plenty of other things to get confused about. All right. So here's our factory, right? And what we have in our factory here is, okay, here's our bird factory. We're going to create a bird. So create a green bird. And creates a green bird. When it creates the green bird, it's going to it's going to create, when you create a game object, it's going to create, this proxy for it. And then it will also create the collision object. And the collision object is going to take the size of the sprite as its argument. So it's going to take in the sprite, and I'm going to use that sprite. I'm going to steal its information, its X, Y, and Z off of it. So I'm going to steal its X, Y, Z, width, and height to use for my collision. So what we have is this. It's going to draw these boxes around each of these aliens. And these boxes are what we actually collide with, right? If I wanted to do this game here, right, I can sit there and put this. So let me go in the factory. Green bird. The game object. So it's right there. Game object there, game object. Instead of doing this, I can put it here instead of. No, I can't do that yet. I don't have enough of the system there. All right, so what we have is this. We create an alien, we create the appropriate collision objects. The collision object, when it gets added here, this collision object adds itself to the sprite box manager. And now we have a sprite box on the screen. So we have this. When you create a bird, so here's the game object.
Does the collision object then keep track of the sprite proxy it's associated with so that
Yes.
it can have its position, everything updated? And you don't have to.
Yeah, everything is self-contained. So this, let's say this is a red bird, right? When we create this, we pass in, like, okay, I want a red bird with this image, right? So image. And this gets created. So when it calls the base class, it goes, okay, create the collision object, right? And because it knows the image, from the image it gets the X, Y, width, and height. It knows now what it's going to do now. It's like, okay, cool. Oh, it says cool. Rectangle, and it's going to use that X, Y, width, and height. So that's what we use for the collisions. And it goes, okay, and I'm also going to create a box sprite, right? And this is all connected right here. Then on our other stuff here, we have, this is our sprite proxy, right? So when we call update, what it's going to do is take the local X, Y, and it's going to move it into that guy and move it into this guy. It will render with this. This will move to here. This will update these guys, and it will update the draw, and then it will render with that draw. So everything's self-contained. So you don't have to really think about how it gets there. So let's look at how this works. All right. So at some point, you say create a game object. So we're going to here. I'm going to create a red bird. Boom, create a red bird. And now remember, on the red bird, we have to go through the whole tree. So game object, red bird, which will create a base, which then will go through the leaf. Goes through leaf. So red bird goes through the base, goes through the leaf, then goes to the game object, and then the game object is going to have the collision object. I'll do it over here, collision object, and then we'll have the proxy. right? So when we create the red bird, it creates the base, which then creates the leaf, which goes to the game object. The game object then creates the proxy, and the game object creates the collision object. The collision object then creates the corresponding box sprite and the corresponding collision rectangle. Okay. So right, so the game object creates these two guys. It's already created the proxy, but now we're going to add the collision object. So let's take a look at that. All right, so here we are. We go to the red bird. Boom. Switches to the red bird on the factory. Boom. Goes up to the base class. Boom. Goes up to the base class. Boom. Up to the leaf. Then it goes up from there. Boom. Now we're at the game object. Game object creates the proxy, the sprite proxy. So you would just say add sprite name. That was easy. That's why the manager is starting to help us, right? Then we create PO, meaning we own it. We create a collision object and we pass in the sprite proxy as an argument. So then we go to collision object. And the collision object goes, okay, thank you, sprite proxy. What can I do with it? It goes, hey, sprite proxy points to a real sprite. Thank you. So now I have a pointer to the real sprite. Now from sprite, the real sprite, I can get its rectangle. Thank you very much. Now from that rectangle, right, I can create a new collision object from that rectangle, create it, associate it, store it. Then I have to create a sprite box. So I call add, it's always a type box, and then add it with those sizes and dimensions. So now, here we go. So now we have a sprite object associated to the game object. And that's why they're locked up with it. If I, in my collision object, here, if I don't create the sprite here, you know, let's see how this works. Yeah, it starts becoming hell. All right. This is where the null objects help out, because you know, if you comment something out, you can turn around and it will still call things, it just won't crash. So anyway, I need to undo this. There we go. So basically we're delegating it, right? So kind of look at this pattern here. How this is being made is kind of like red bird. Then it goes up and creates the bird base. Then it goes up and creates the leaf. Then it goes up and create the game object. And then the game object says, okay, I will create the collision object. This is the ownership, that's why it's a diamond. And then this guy will create a rectangle, right? And this will create a box sprite. And we make sure that that diamond's right for that. So we're in collision object. Collision object. It points to the sprite. It doesn't own the sprite, but it owns the rectangle. So yeah, that's right. And then this points to this points to a proxy sprite, which then points to the game sprite. Right. And the reason why this one is a aggregation is because over here we have the proxy sprite manager, and that owns the proxies. And so this just essentially points, this essentially pointing to one of those. So it doesn't own it, the manager owns it. And what's nice about this pattern is then this is self-contained, that's self-contained, this is there. Again, the sprite box manager, so box sprite manager, it owns box sprites. So this points to one of those. So this is kind of how that thing's being created. Right. So what's happening is here's your alien. Here's your alien. Right. And then what I'm doing is I'm sitting there saying, okay, this collision. This is the collision box. In the upper corner is the box. Right? So upper corner. Origin is the upper right corner. That doesn't make sense. It's upper left corner. All right, so and then this has a certain width, a certain height. All right, so there's our guy. So now we start to do more things with this, right? So here's where the fun comes in. We now put these guys in collision hierarchies. And collision hierarchy just becomes we're just using the composite pattern now. And so what we have here is this. We have to see if I'm wearing anything else. We have this. So here. Okay. Go down to this. We have the factory being created, boom, boom. But we also created the grid and the column, and we attach things to the column, right? And what we're going to do is I'm going to have each of those three birds, the red, green, and yellow bird, each move differently. And so I just can the movement. So game object. So the green bird, let's just say move up and down. That's it, just move up and down. And then the red bird, I'm like going move horizontally. And then the yellow bird, I said, okay, yellow bird, move horizontally. And I have these moving at slightly different rates and slightly different spans. And the idea is that these little birds are moving around, right? And it's going to create this, this box that goes around all three of them. And so this box that goes around all three is the column. Right? And so the column, so we go in the bird column. When we say update, it's going to grab the iterator of all its children. So here's iterator, all its children. And basically it's going to say, okay, cool. It's going to walk through the linked list and union the collision boxes, right? So here's the problem, like what is a union, right? So let's say here, we have box A and box B. What's a box that goes around them all? Well, it would be the most left, right? The most top, the most right, and the most bottom. This is the union of two boxes. So now how do you deal with three? So if you had a red one, a blue one, a green one, let's say over here, right? What you do is you union any two together, then you union the union. So you treat the union as one, and then the next one. We give a, let's say, a different pattern. So you union the first two, and it doesn't matter which two, union these together. Then you union the union. So it's be the outside box. And to kind of shake that out, have each of the boxes moving in different locations, and the column is drawn blue. So you can see as it moves, it's like kind of almost pushing that wall in and out. But what's happening is actually just calculating the volume every single time. So it takes the first two, calculates the volume, then the next two. So here, let me comment out, and we go through the first one, next one. Let's do this. All right, so see how those two are tracking. I'm getting the box glued together between those two. And it didn't add the third box because I aborted out of the loop early. So, so what we're doing is we're iterating through and calling union. So whatever I initially had, I union the new rectangle with it. Then loop through again, whatever I had, I union the next new rectangle with it until I finish. So the collision of the child's or children will be put together as the super or the uber, right? So what this means is this. I have column 0, and then I have three birds, A, B, and C. And so when I update this, I have to update move A, then move B, and move C. Then when I sit there and say, okay, now update the column, I go, okay, what is your box? Add it. Then what is your next box? Add it. And what is your next box? Add it. So I'm unioning this up. So if we had right, it's going to do the first thing it does is it does its it sits there and say, okay, it does its level, nothing, so it's empty, so it's a 0 box. Then it adds C, then it adds A and B together, then it's going to add that union, oops, that union with the previous union, and so it's going to now bring in C. And that's going to be the collision box that C uses. So the idea is that you would have
That the column uses, right?
the column uses, right? So you would have, let's say 3 aliens here, 1, and then, 2, right? And the column box would automatically be generated to this automatically. And then the grid will use 3 columns and it will generate this grid, right? Then when you go in there and you shoot this guy, like, right? You have to make noises. Then this goes this way. You're like, then all of a sudden somebody goes and kills that guy, right? And boom, this shrinks. Then this shrinks, right? And then when somebody shoots this one, it gets deleted and removed, and then this becomes our column. Then as you shoot the next one, now here's what you have. And so even, here, it will still have all 3 height. But that's all we're colliding against instead of a large fat tree. So this is kind of getting us into the framework ready for that. So all we did is add a union. So the next part of this is what I just described, is we really have to move the guys on the bottom first. So we have, here's the grid. Here's the columns, right? Here's the aliens. Right? What we really need to do to make the collision system work, we have to update this level first before we update this level, before we update this level, right? So when we're talking about our iterators, normally our iterator starts from here and goes down, down, across, across, then to this one, then down, and then across, then this one, and down, across, and we're done, right? So this is a forward iterator. Right. What we need is we need to do this whole guy backwards. Because we have to update the bottom row before we can update the next parent level. So this backwards approach I call the reverse iterator. And this is this way we update our tree from the children to the parent ordering. So we can never update a parent unless all the children have been updated. It's you have to first buckle the kids in before we buckle ourselves into the car, right? So this is kind of their process. So our new problem here, and I'm gonna like throw my hands in the air at this right now because of time wise, is we need to do a reverse iterator. And so that's going to take a little more logic to figure out how to do a reverse iterator on there. And that's just a process from the bottom up. So when you
Isn't it
have
just
that,
we have a double linked list, so wouldn't you just have to track where your tail is of like the very last, or like, I guess the rightmost thing of the tree?
it's a little more complicated because you have still hierarchy.
Looks probably simpler in the picture. It's like the Amazon thing again.
Well, first of all, how do you know it's this node, right? The first question is, how do you know this is the start? You're given the head. How do you know to start down here?
That's what I meant by track a tail, like similar to the D-link list.
Oh,
where
I
you-
see what you're saying. Track
Yeah.
yellow forward. Yeah, that might be a technique. Because then you could,
Cause you already have the tail logic in the underlying D-link lists.
so you go this way, right? Boom.
Yeah,
But then you go, once you hit the first node, you go up to the parent, which is easy,
Yeah.
right? Then from here though, right? You have to go over to the previous sibling
Yep.
and then to its tail.
yeah.
That's totally doable. But that becomes, there's a couple different ways to kind of approach it.
Mhm.
What I found was the easier approach, which your insight is really spot on. I like it. But an easier way might be is, why don't you just add a node and figure out what would you do if you're going to reverse it? Add this, then what would you do to reverse it? You start seeing the pattern of how to modify your links. Now, what I wound up doing was burying inside each node a reverse pointer. So anyway, so we have to do the reverse node, right? So here's the question I want to leave you guys with, get you thinking about this. We're now up to the point, which is kind of the head screw section of this class. It's called the visitor pattern. And the visitor pattern is, we have this problem, right? Here's a person. And here's a car, right? And the two hit each other. Who hit who? Who hit whom? Did the person hit the car, or did the car hit the person? I want to do a certain effect for that. And so that this is the problem, is that, did the person walk into the car? Did the car drive into the person? Did they both run at each other, hit each other? Who owns that collision? Because two things collided. Who's responsible for this thing? And when I mean responsible, who removes the other two, removes the person from the screen, removes the car from the screen, who gives the points, puts up the points for the person in the car, who sits there and puts the explosion, the big explosion, splat that goes on the screen right where they collided, right, in the puff of smoke. Who owns it? And that turns out to be quite an interesting problem, is trying to figure out who collided with whom, and you want to have one reaction with this. And so the pattern we're going to go explore is the visitor pattern. The visitor pattern uses a concept called double dispatch. And basically, at some point here, you're going to sit there and say, car collided with a person. Now you're in the person, you go, person reacts to a car, trigger off events. But if you call it in the other order, you see a person collided with a car. Now a car does a reaction to a car hitting a person event. So you're gonna need to know, given 2 pointers, which guys collide with whom. The reason why this is tricky is because at first we don't know anything. We just have game object collided with game object, right? And we don't know that there might be a hierarchy mess underneath this. And now we need to know all we're colliding is at this level. We're just saying these two collided. And we're supposed to sit there and say, you know what? A person and a car collided, and here's the reaction. Or if I swapped the two rounds, so this is A and B, what if I did A versus B? I have my reaction to the on the car. But if I just take the same two things, but they're in linked lists or they're in orders, right? And I just sit there and say, oh, I go B versus A. Now my reaction's off a person. So how do I, first of all, tell which two things actually hit each other? And second thing, have one reaction. Because I don't want to code up everything on the car. Then all of a sudden our linked list is different ordering. All of a sudden now, shit, the person hit the car, not the car hit the person. And now I have to code up a totally similar mimicked reaction. But now I have two sets of codes and two locations kind of thing. So this is what we'll go through next week in heavy detail. All right, so questions, issues.
Is the stuff that we'll be going over next week integral to the milestone?
Nothing after this point. There's nothing more needed for milestone.
Right.
Right. Doesn't mean, you know, and this is where a lot of students get into trouble. They're like going, cool. Next week's material, I don't have to pay attention because I'm working towards my milestone. All that means is if you don't keep staying with this material, the whole point of the sprint isn't for you to stop and now work when I give you a sprint. You should be working all along. The sprint's the kick in the pants if you aren't working, if you're not following the lecture. If you're waiting till the sprint comes out, you're already sliding behind. Sprint is just a kick in the pants to keep you going, right? So if you haven't been following up with, you know, like the, you know, last week's material, right, the factory and the proxies and that, that's just assume that every class is assuming that you're on top of the material that I cover. So the sprint is just a kick in the pants saying you're falling behind if you don't have, if you're not at this level. So I'm just giving you a warning next week, stay with it, because next week is all about collision and the visitor pattern, and it's rough. It's definitely rough. This is the part that kind of kicks people's butt. So, but for the milestone one, you know, this first milestone is like, we're going to do the screen will be proportionally correct. I'll give you the dimensions on this, but each guy, the alien, you know, have to look correctly, you know, space, proportion, right? The crabs, you know, has to be spaced and proportion correctly. And then there's a squid, crabs, and then the octopus. I don't know what to do with octopus. I know I'm getting this all wrong. Those are going to be proportioned correctly. And you're going to have all these on the screen, and they're going to be marching. Marching means, you know, dunk, and then the next step, dunk. Next step, dunk. Next step, dunk. You know, think about it as a war beat painting. So this is look up. This is pop-up videos, right? So pop-up videos. Just, you know, we're not going to shoot, and they're going to move perfectly aligned. Just a little bit staggered.
So they do just bounce back and forth. It doesn't loop around, right?
No, it just goes back and forth.
Okay.
Back and forth. That's it. And then as we, you know, go more about the collisions, you'll see that you hit a fake wall here, and then you change and go down and turn around and go the other direction.
Do I have to implement this going down right now, or just go side to side?
Excuse me,
Do we need to implement this, the lines going down, or just go side to side?
side to side, side to
Okay.
side. And it has to be, what happens, this is where a lot of people get this wrong. First of all, you know, you have to use and there's quite a bit of patterns, right? So there's a lot of patterns there. There's a lot of structure to this mess, right? But here's where people get in trouble. They have the guys moving and he's just drifting, you know, just drifting. And then, you know, then it's what it moves and it just kind of drifts. Really, it's supposed to be bump, then they move, you know, a little bit over, and then they land this way. Then they move a little bit over, and then it's the other pattern. They keep adjusting patterns as it moves, like dunk, dunk. There's no continuous. It's discrete moves. And how do you keep that straight? You're going to have your timer going on. Timer event, you know, timer event will dunk, dunk. Think about the drum beat, like of those old warship, you know, the pirate ships where they have a guy in the bottom of the boat, and all these indentured guys are there chained up to their oars and they're row, row, and they have this drum guy go dunk, 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 dunk. And basically that's what's happening, is the timer's telling you when to march. Every march you move so many units over, you change the animation. So many units over, you change the animation. It has to look perfectly lockstep. Having it animate and smoothly move back and forth isn't step. It's supposed to step, go dunk, then boom, lands next step, the next step. You can't be smoothly moving back and forth. And this is going to force you to use a timer. The timer is going to not only charge you on when do you move, but also your animations. So the way I see the timer being used is that you have your timer, and you sit there and say, okay, here's my delta time, whatever that is, and you'll have commands. And the first command might be move at time, we'll say 55, 55, 55, 55. And this is move, the grid. That's one command. And then this might be animate, squid, octopus, and crab. So these are all animations, right? Then when this is all done, they get removed off the list, and you're going to turn around and re-add them on the list at another delta time. These are all at 73. And you're just going to keep calling these commands, moving, calling these commands, moving, calling these commands, moving. Because remember, you can have multiple events happening in a timer at the same time. And because these are in priority queue, when let's say the time is 56, you go, oh, trigger, 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 and you stop, you don't do anymore. And when these get pulled off, they get a delta time and they get added back on to the tree, and to the list.
So do we even, since we're reusing all the commands, would we just create those once?
Yeah, and
add them to the list, and then they just keep getting reused. We don't even need a manager for them or anything.
Right.
Okay.
Yeah, and that's the nice thing, is you keep just reusing those.
Mm-hmm.
It's much easier, and there's going to be a part of you that's like going, why don't I just have one timer event and it will move the grid and animate all these 3 different types of aliens, right?
Mm-hmm.
Keep them as 4 separate items, because later they're going to do different things. When you take a snapshot at the end of this course, what the timer is doing, the timer is going to have hundreds and hundreds of different commands on there. Your timer should just handle it. Should be no problem with it, because it only triggers the one that are closest to the time. You know what I mean? Because of the.
But there are still some one-off events, though.
There are some, but not many.
Okay, so we'd still be using news and stuff for those, because they don't happen that often.
Yeah, and later I'll explain a way how you can even stop that. So let's say it's an explosion splat, right? You do the splat, you know, you use it for a little bit, then you remove it. You can put it onto a manager that is, I call it the ghost manager, and then you can resurrect it from the dead
Mhm.
and reuse it. So you can have dissimilar types of objects in a recycling pool too.
Okay.
For right now, we don't worry about that. This one's oh, you know, you're supposed to have sprite batches as well on here. So there's be sprite batches in addition to this whole mess. Yeah, sprite batches should have it here.
They don't look like they're on there.
Okay, well, they will be. You know, so this really gives you the ability to see a lot of different things. Yeah, this is, I don't know what I grabbed this from. I lost a lot of things when I lost my, oh, here it is. Iterator uses sprite batch manager.
Oh.
Yeah. I lost a lot when I lost my computer. So I'm like still every day finding more things I lost on that computer, which is making me sad. All right, other questions? The reason why we're doing this is then very next thing after this is, you know, we're getting into collisions. Then after collisions, we get into listeners or observers. We get into strategy patterns. And pretty soon, poof, the game's, we have all the infrastructure and the game gets made in essentially a week.
I just kind of wanted to clarify, like, because I know, you know, because obviously, you just want us to follow the patterns generally. We don't have to be like dead on with exactly how I have everything in the examples. Like, you want us to use the patterns, like you said, but
Yeah,
we have some kind of
you can use your own naming.
yeah.
Remember, at the end of the day, what a pattern is the wires that are connected, right? So like, let's take the command pattern, right? The command pattern is, you know, here's the command pattern: execute, right? The concrete class, you know, so we overload this, right? And then this will do work on, so this will do work on a receiver. Right, so this is some receiver here that gets the work. Right, so that's the command pattern. All right, what you call it, I don't give a care, right? You might have multiple functions, right? You're going to have to overload in your concrete class, and then you're going to do work on somebody else. So this is on a receiver. EIVR. You're going to be doing on the receiver. So when you create this class, somehow you have to pass the receiver in there. So how do you pass the receiver in there? When you create this class, let's call this class movement, right? You're going to have to pass something into the movement. So in this case here, you would have move, and then you might pass in there P grid, right? And so now this will do its action on P grid dot move, and you might say 5. And then this is the grid, right?
Right. I get it.
So now your choice here, you don't have to use the same names. You can have multiple, you know, things. You can add more fields. Like, well, this is a base class, but you know what? I could still add some other methods there, some other data in my base class. I just have to make sure I implement it here because this is the contract, right? So you have a lot of latitude here. It doesn't have to say call command. I think it makes sense to call some of these things commands, some of these things called proxies, just because it keeps your head straight, but you don't have to, right? So a proxy, right? You know, here's something small, you know, X and Y, you know, and then you have a pointer to the real guy that has, you know, bazillion data points. And here's your XY, but then it also has a lot of other elements here, right? So your whole thing is here is that you point to the real, and here's your proxy. There's a push, and you replace that data with yours. So you take your data and you replace it. Then you do an action on the real. That's a proxy. What you want to call it doesn't matter, but that's the key cornerstone of what a proxy is, right? You know, what's the other one? Singleton, you would have one instance of this. You know, how do you control an instance? Is it a static instance that nobody sees, or you actually do an external? Here's the pointer to it. You know, I like the private one because it's kind of hidden. I think there's some benefits to that. What were some of the other patterns? Factory. Well, you just saw us use factories many times there. How you do that, what's inside your factory is really up to you. I just keep rapidly prototyping a factory, and you know, like I start burying more and more things in here. So towards the end of the project, my factory is taking in 3, 4, 5 arguments, and then inside the factory, it's becoming more and more complicated in here. And it does a lot of attachment, attaches collision objects, does all these different things in here. And then it just returns like, here's your pointer. So I actually have, we get further down there, I have a factory that creates grid, which then creates the columns and aliens, and all I can return back is the grid pointer.
Mhm.
You know, and just bury it. So then I don't have to worry about this, and I do it once and I forget about it. I have a factory that creates a shield, and I just call the factory 4 times with a different start location. Now I created 4 shields. So that's kind of like the idea is that you start letting these patterns work for you, right? Iterators, right? You know, what are you going to use for the iterator in here? Well, a good example here is the iterator in the Sprite Batch Manager, right? You know, go through there and go start at the beginning, go ding, 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 and you just do this, and it just draws. You know, so like in the Sprite Batch Manager here, you will see the game update, draw here, iterator first, go through this, and it walks through the draw, which then turns around, goes to the draw manager and does the subtree. It grabs its iterator and draws it. So there's an example of 2 iterators being used. You know, adapter, you know, this is like basically insulating you from the texture manager, right? Templates we're using all over the place, going up and down on the manager classes. Commands are going to be all from the movement, proxy, priority queues for the timer, object pooling we're using in the image manager. So I mean, I give you examples where we're using it.
Yeah, that's what I was about to like say. It was like that's like the prime way you want to see it, you know. And it's
Yeah,
pretty much
and all I
there.
want to do is I want you to show me that you're using it.
Mhm.
And,
Yeah,
and
I get it.
if you give it different names and you have this, now what you're going to see a little bit later, I'm going to use a observer event, which is also command, which is also a strategy. So I have one class, and kind of like if you look at these 3 links, it's a command. If you look at these 2 links, it's an observer. If you look at this link, it's a strategy. So it's one class, and it has 7 different abstract methods, but it's doing 3 or 4 different jobs. So the key here is these are all single jobs, so they're much easier to dissect it. And then later we're going to be starting bang them together and make it a little more complicated.
Mhm.
Does that make more sense?
Yeah, a lot of
Yeah.
that makes tons of sense.
Yeah,
Thank you.
and the catch is, Murray, I said from the first day of class, you can probably do this whole game in a weekend in a
Yeah.
in a for loop. This is just a vehicle to force us to use these techniques, and these techniques are kind of powerful. You know, so I appreciate everybody bearing with my iterator nonsense, and I'll correct that. But I want to make sure that we kind of get some clarity on the iterator. stuff. You know, more I think about it, the first, it should probably also reset the iterator to the beginning, because you should be able to call a for loop, then turn around, call for loop on the array again, turn around, call a for loop array on the again, and then only works is if your first also resets the state. And I'm leaning more that way now. All right, I'm gonna let you guys go. You know, this is it. The visitor pattern is ugly. I'm just telling you up front. It's one of those things where if you were in an interview and you said you know design patterns, I would just sit there and have you explain to me in English how the visitor pattern works. And I would say majority of people who done design patterns cannot really explain the visitor pattern. So it's the only complicated thing in OO design. It's a visitor pattern. So we'll go through that next week and then start making things collide. So it's class gets really kind of cool. We're turning the corner right now. Okay. All right, I'll get this stuff out so you can start looking at the milestone and start to panic. It shouldn't be, there's nothing new, but you're going to have to be more precise. You're going to start to finalize things. You're going to have real aliens, proportions, the screen. So you're going to be more focused on details. Okay. All right, I'll let you guys go. Thank you.
Thank you.
Thank you.
Thanks.